but I don't remember what it was.
Oh, nice. If we could try number 3.
Yes. So let's start with number 3. Oh, never mind. So you want to start with number 3. So you're fed up with 1 and 2. It's very clear, right? Okay. I think we beat those to the ground, didn't we?
Yeah.
Okay.
I feel pretty good with this.
Good. I'm happy.
Unless someone else wants to do it.
Now remember how a little bit of a struggle it was at the beginning with those two, and now you look at them and say,
Right.
Yeah. So that's pretty good. But initially they were intimidating, weren't they?
Yeah.
Good. So I met my target. That's awesome.
Initially, the charts were like.
Yeah, the charts were so confusing before, but now I've seen so easy.
Yeah.
It's all about practice. There's
I even drew one on the exam.
Very good. Okay, we have an agreement. And I hope you will never forget that agreement. We have an agreement on 3 different things. Well, they're not that different, but yes. What will you say? Believe me, moving forward, knowing that and not having to foil it all the time,
Yeah.
you're making a leap forward, not a step forward.
Yeah.
In the meantime, everybody else is going to foil on scratch paper because they were kind of not forced, maybe, to remember the pattern.
Yeah.
It will be so much easier. So what do I have? Yes,
Yeah. 1/4 x to the 4th.
plus.
1/2 x squared.
Yes, because it's 2 times 1/2, which is 1,
Right.
times 1/2.
Which is half.
Right. So I have 1/2 x squared y squared.
Yep. Plus 1/4 y to the 4th.
Right. So all I have to do now is combine like terms and rearrange it like this.
So you
So
end up with 1/4 x to the 4th minus 1/2 x squared y squared plus 1/4 y to the 4th.
see how important it is to be able now to go backwards by simply looking at it?
Yeah.
And it's done. So what do I write? The square root of?
Yeah. 'Cause it's
Remember, this
that, but it's,
is this.
It's a negative instead. So it'd be 1/2 x squared minus 1/2 y squared.
and everything squared because I know
And
that
everything
this
squared.
this binomial squared is this trinomial. Good. So now the final form. Remember, I have to use the absolute value here because it's a minus.
Yeah.
This is always a positive quantity. This is always a positive quantity, but the difference could be
Yeah,
negative.
absolute value of everything.
Right. But the difference could be negative. That's the reason why I have to write this.
Right.
If I had positive and positive here, let's say, and if I had positive here, then with positive, I would have not used the absolute value. Because this first quantity is always positive, the second quantity is always positive, and their sum will always be positive. However, the difference of two positive quantities is not always positive. That's the reason why I need the absolute value. Good. So,
Is there more?
that's it.
Oh.
This is the final answer. There's nothing else I can do here. Next problem.
We do 9.
Yes.
Just what it's-
Yes. Very good pick. A lot is done with piecewise defined functions in Calc 1. beyond, a lot. Like with the difference quotient. If you remember, I said the entire chapter 2, first chapter in calculus, deals with the difference quotient and nothing else. Okay, and the rest is based on difference quotient. Okay, you said
Number 9.
you said number 9. Very good. So we have f of x, 1 over x minus 1, and x greater than 2, and x squared minus 1 for x less than or equal to 2. Very good. First, I have to identify what?
Restrictions.
Yes, and the domain, in other words. Correct. Very good. That's the correct answer. Perfect. So this is a quadratic function. It's defined definitely everywhere. This is a rational function, and it's not defined at, but 1 is not in the domain.
Right.
So in interval notation, can anyone give us the first?
2 should be positive.
And
Parentheses.
very good. And this one?
Bracket.
Because it's to the left, I have to start from negative infinity,
Okay.
right?
Yeah.
So negative infinity, comma, 2 with the bracket. Very good. So obviously it's very clear that this function is defined where? Correct. No, nothing is missing. So I have to have 0 in the chart and 2. And if you like my method, however, it's not my method. I was taught this way. I will not take credit for it. I will use a bracket to the left, and I will use a parenthesis that touches. If the function is undefined at 2, these two symbols will not touch. But since the function is defined at 2, how will it look? How will my chart look under 2 if the function were not, by any chance, defined at 2? It would look like this.
Yeah. Oh, you wouldn't touch them. Okay.
No. Just to show that the function does not exist at 2. And I have a number here, whatever the number is, and I have another number here, whatever. They may be the same, though.
Okay.
And maybe a hole in the graph. If these two numbers are the same, it's a hole in the graph. So although this is an overkill, I think it's a good and safe procedure to write right here at the top, because these may not be in the correct order, and like they are not here. See, between negative infinity and 2, I do have to use x squared minus 1. And between 2 and infinity, I do have to use 1 over x minus 1. This was intentional, right? So if you haven't paid attention that the first part is basically the bottom piece of the function, and the right-hand side of from 2 to the right is the first one, then you could possibly mess it up.
Right.
Okay, so be careful on that. Good. So now I know that this is quadratic, and I remember how to graph this, right? It's x squared and down 1 to the left-hand side of 2. So I'm going to use a negative 1 and 1, of course, and I'm going to put 0 as well, because I know how to graph it. It's already in my head, right?
Yeah.
So when I plug in negative 1, I know what happens.
0.
Yes. When I plug in 0,
Negative 1.
correct. And when I plug in 1,
0.
correct. I still have to plug in 2, because that's where the threshold will be. So when I plug in 2, I get,
3.
yes, right here inside the bracket.
Yeah.
Now on this side, let's plug in 2. 1. Do I know this graph? Yes, I do. If you remember, the graph looks like this.
Right.
Right, with a vertical asymptote at 1, of
Yeah.
course. So, or it's 1 over x shifted to your right, 1. So we already know how to graph that. So let's use another value, because I need 2 or more.
Mhm.
So when I plug in 3, I have 1 over 2, which would be 0.5 on 1/2.
Yeah.
Good. Okay, so now let's graph. So I will start from the left. So slowly, step by step. Negative 1 comma 0 is this point. 0 comma 1 is this point. 1 comma 0 is this point. 2 comma 3, 1, 2, 3 is this point, and it is a full point, and I'm done with the left-hand side. And this continues, but here it has to stop. So that's the left-hand side, between negative infinity and 2, for x values between negative infinity and 2. Now 2 comma 1 has to be an open point. I already know that this graph has to have a horizontal asymptote. It's type 1. I'm sorry, forgive me, it's type 2. Higher degree in the denominator, which means the horizontal asymptote is
0.
0. Very good, awesome. Y equals 0, horizontal asymptote at infinity only. So see how important all our discussions were, and especially now at the very end, when we really go back and review and connect things and say, okay, this is what we did in chapter 3. Now I can connect it better with chapter 2 when I looked at piecewise defined functions. But at that time, I couldn't have something like this because I really didn't know how to graph the rational function. I didn't know about those 3 types. I didn't know what it meant. I didn't know horizontal asymptote, a vertical asymptote, and so on and so forth. So this is the graph of the function. It's a piecewise defined function. And an obvious question here is, what is the range?
You're 1 to infinity.
Very good. From the lowest y value to the largest y value, as long as I have an arrow pointing up, it goes to infinity. Very good. Very good. Awesome. Now, we're not restricted to this. You can say, I still would like to see a problem like blah, 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 blah.
Mm-hmm.
This was our starting point.
Can we do 12?
Yes. Find the values of the remaining 3 functions of t from the given information. So in number 12, we are given cosine t equals negative 4/5, and we are told that tangent t is a positive number.
Right. So we need to know the quadrant
Exactly.
where tangent is
So
positive.
that's why we needed 2 pieces of information, because just knowing that cosine is negative, I know which quadrants am I looking at.
3 and 4.
Careful.
Oh, sorry.
The your left-hand side, 2 and 3. But once I'm told that tangent is positive, I know exactly which quadrant that is.
3.
Yes. So t is in the 3rd quadrant.
Right.
So basically the problem is asking me to find sine, right? Once I have sine, I have the other 4.
Yeah.
Because they all the other 4 depend on sine, cosine, or both.
Right.
So since I know that t is in the 3rd quadrant,
Yeah.
I would write that sine t, and you don't have to use this. You can use the triangle, right?
Right.
But I can use this. I prefer, that's me, you don't have to. So it's 1 minus cosine squared t.
Right.
And all I have to do is plug it in. You can say this is longer, and it's more difficult. I want to use the triangle. Use the triangle. No one forces you to use the identity. So this is negative the square root of 1 minus, when I square this negative number, I get 16 divided by 25. And 25 minus 16 will be 9. The square root of 9 is 3, so this is negative 3/5. Once I have the sine and cosine, I'm done, basically.
Yeah.
So what would be tangent, for example? We are looking at 12.
what did you ask? What is tangent?
Yeah,
Tangent is 3 over 4.
exactly. What is cotangent?
4 over 3.
Yes. And what is secant? Secant depends on cosine. It's the multiplicative inverse of cosine. So it's negative 5 over 4. And what about cosecant t?
And that one's negative 5 over 3.
That's it. Again, I prefer to use the identity, and the reason is because who knows, I may mess up a sign in the triangle. But not necessarily. You don't have to use this method, right? So how will you use the other method with a triangle? You will graph, so this is in negative 4/5, right? So you will have an angle that ends here, right? So you'll have to look at this. So this piece and this piece. So the negative 4 is which one?
This little smaller one, right? Because it's on cotangent.
So cosine.
Is
so we are given
adjacent
cosine.
over the hypotenuse.
Yes, so we are given cosine t equals negative 4/5.
Yeah.
Right? So this has to be negative 4 and this has to be 5.
Yeah, that's what I'm saying.
Right, okay. So I wasn't sure. So then this is definitely 3.
Yeah.
Because 4 squared plus 3 squared equals 5 squared.
Yeah.
But it's me, I may forget to put the negative if I don't put it from the beginning. So that's why I prefer this. But this is perfectly fine, and this is shorter. Good. So that was 12. They're all pretty much the same. There is nothing unexpected.
13.
13. Yes. Very good. Any questions on 12? Okay, so let's look at 13. 13 we have f of x equals x squared minus 1 divided by x squared minus 3x plus 2. After you carefully read the question, always look at the function and do not draw conclusions before you clean it up.
Right.
So in most cases, you will be given something to work on. So to show your expertise now. So I will not draw any conclusion. Well, at this point in time, I can say it's type 1 because the degree of the top and degree of the bottom, yes, definitely. So I will definitely factor completely the top and the bottom into x minus 1 and x minus 2. Remember, you cannot simplify anything before you write the restrictions. If you simplify, then the restriction is gone. You're not going to write it anymore. So before you simplify, or always keep in mind this, I am not allowed to simplify before I am sure that the operation is legit. The operation is not legit if I don't write x not equal 1 and x not equal 2 first. Now the operation of simplifying becomes legit. So x minus 1, 1, x minus 1, 1. So this function stays as type 1, but much easier to handle. But now I know what happens. So what is the domain, first of all? Because I have to write the domain. I have to fill out my chart. Again, if you decide to take my class, and if I get that class, I will build on this chart in Calc 1. 2 other rows will be added to this particular chart. One will be the first derivative, and the other one will be the second derivative. I'm sure by now you know what I'm doing with this chart.
Yeah.
And what's the information that I put in there, and once I fill it up, I know it's done. Okay. Domain.
You need to find out what the exclusions for
Right. So they're here. So then I write negative infinity, 0 has to be in the chart,
Right.
1 has to be in the chart, 2 has to be in the chart, and infinity. So always remember the numbers have to be in ascending order from negative infinity to infinity.
Yeah.
So if you put 2 here, the whole thing collapses.
Right.
Okay. Good. Now I know, because it's type 1, I know what is the horizontal asymptote. In type 1, the horizontal asymptote is the leading coefficient over the leading coefficient.
Right. So 1.
1. So this is 1 and this is 1. The end behavior is always the horizontal asymptote or slant if it doesn't have horizontal. So underneath I write y equals 1 is the horizontal asymptote. Now let's go back to x equals 1 and x equals 2. What can we say about these? What can you say about x equals 1?
X equals 1 factored out, it's a whole.
Yes, x equals 1, a hole in the graph. So here and here, I will find the same number, not infinity. What about x equals 2?
It's a vertical asymptote.
Very good. X equals 2 will be in a vertical asymptote, and I know this has to have infinities left and right. I know that for sure. But what I don't know is the sign of those infinities, and I will check the sign with 1.9 and with 2.1. Okay, so let's finish up this. So let's plug in 1 here. 1, not in the original, because in the original I have 0 over 0, and that's indeterminate.
Yeah.
So I plug in for the whole, for the numbers left and right, I plug in the simplified form. 1 plus 1, 1 minus 2. The top is 2, the bottom is negative 1, so it's negative 2 indeed. Negative 2 here and negative 2 here for sure. So I know that the open point or the hole in the graph has what coordinates? Although it doesn't exist, what are the coordinates?
1, negative 2.
1, negative 2. Excellent. So now with 1.9, the top is definitely a positive number, but the bottom will be negative. So that's how I know the sign. Also, you do not have to do this on paper. You can put the function in y equals and just punch in those 1.9 and 2.1 to find the sign. But I think it's too easy. There is no need to do that. It's up to you though. With 2.1, the top is positive and the bottom is positive, so this will be a positive infinity. I know I'm getting close to filling up the chart. I need the x and y intercepts. So here is 0. 0 here, 0 here. 1 and negative 2. So this is very good. And now, always remember, a ratio is 0 for the x-intercept. A ratio is 0 only if the numerator is 0.
Right.
So x plus 1 being 0 means x equals, I filled out my chart. I know I'm done. The only thing that is missing here is the symmetry. The only thing that does not fit in the chart anywhere, and I cannot write it, I will write it next to the chart, is symmetry.
Right.
But a function with a vertical asymptote at 2 and a hole in the graph at 1, can it be symmetric?
No.
Symmetric means symmetric with respect to the y-axis,
Right.
or symmetric with respect to the origin. No. So the only thing I should write, especially in a test situation, I would write that f of negative x does not equal f of x, meaning not even, and it does not equal negative f of x, meaning not odd. So then my professor knows that I know what I'm talking about, but there is no need to plug in negative x. It's a waste of time. And this is good enough. Okay, so now I'm trying to make sense of the information and see if I should even put it on paper. Okay, from approaching 1, it crosses at negative 1, 0.
Yeah.
It crosses at 0, negative 1/2.
Yeah.
It goes through an open point at 1, negative 2, and approaches negative infinity on the left-hand side of the asymptote. Right? So from approaching 1, crossing the x-axis, crossing the y-axis, crossing that open point, and approaching negative infinity. On the other side, It's coming from positive infinity and approaches 1.
Yeah.
Pretty straightforward. So when I graph a function with asymptotes, I have to graph the asymptotes first, and the hole in the graph too. So I know I see y equals 1 is the horizontal asymptote. I see x equals 2 is the vertical asymptote. And 1 comma negative 2 will be this point, an open point. And now I'm ready to graph. I also have negative 1, 0, which is this point, and 0, negative 1/2, which is this point. So on this side is positive to infinity to 1. On this side from approaching 1, crossing, and approaching negative infinity on the left-hand side. These problems get very hairy in the next class. But we have other tools in that class that we learn that will help us. So now if we're asked, for example, the range of this function, what would you say?
Negative infinity to 1 parentheses, union parentheses 1 to infinity parentheses. Oh, not that either. Right.
So negative infinity to
negative 2 parentheses.
negative 2 parentheses union,
Union, then negative 2 to 1.
union,
And then
Well,
1 to infinity.
exactly.
Yeah.
In other words, everything except negative 2 and positive 1.
Yeah.
A little tricky. Good. So let's look at anything else. As you see it on this final, I gave all the equations of the conic sections. However, I did not specify which one is which. But we do know that the first one is a if it has minus.
No, not ellipse. Ellipse has plus.
Exactly.
The other one,
This must be the ellipse, so it's a hyperbola. What is the second one for sure?
circle.
Exactly. This one is definitely an ellipse, and these two are two different types of.
Rhombus.
That's it. Good. Next question. What would we like us to work on next? Anything else?
Is it 18?
Yes, 18. Very good. Sine to the fourth. Very important type of problem. However, I have to be honest, it's for Calc 2, not for Calc 1. Okay, so this is basically sine squared squared. Anyone remembers sine squared? We have to remember these two. They're really important. So they are both are the same. Sine squared and cosine squared are the same, just the sign in between is different, is the opposite. So for sine it's minus. For cos,
Cosine 2x over
yes, 1 minus cosine 2x over 2, and that's what I have to square.
2. Right.
Please leave 1/2 outside as a 1/4. And then 1 minus cosine 2x squared. And please remember the agreement. So 1/4, and then how many terms will you give?
3.
Good. Very good. Awesome. This is a huge, as I said, a huge step forward. Yes?
Minus 2 cosine 2x plus cosine squared 2x.
Good. So this is done, but I have a problem here.
Yep.
Because it still has a power other than 1.
Reduce it again.
Yes. So now this is exactly the same thing, but I have,
Plus cosine
yes, but plus and, yes. So 1 plus cosine 4x divided by 2. So I will replace it. I will find the LCD inside. Do not go outside. There is no point at this point in time. Do not go outside. Leave 1/4 waiting. Let him wait outside, him or her. I know it's rude, but 1/4 will not be upset. So 1/4. Find the least common denominator now. Yes, 2, indeed. Then
yeah, 2 minus 4 cosine 2x.
and now since it has denominator 2, all I have to do is copy. Now if you want, you can multiply and get 1/8 in front. That's good. And then at the end, we can distribute it. But what is left in brackets? You have the 2 and you have the 1 up here. So this is a 3 minus 4 cosine 2x plus cosine 4x.
Yeah.
And it's done. There's no more lowering powers because cosine has power 1.
Yeah.
Different arguments, we don't care about that. You will be able to integrate this in Calc 2 now. So now this is 3/8 minus 4/8, which is 1/2 cosine 2x, and 1/8 times cosine 4x plus 1/8 cosine 4x. Any questions? Okay, next problem.
19.
19. A, B, or both? Okay. 19, we have 3 raised to x minus 1 equals 2 raised to negative x plus 4. I will always ask myself, first question, what? What is my first question?
What type of equation is
Exactly,
this?
exactly. Once if I am able to identify it correctly, chances are high, right, that I will be able to, okay, good. So what do I do next?
Hello?
Yes, I ask myself, can I present 3 and 2 with the same base? No way.
No.
So Stephen is right, I have to apply log. It doesn't matter which log I apply, but it has to be the same on both sides. So let's apply log this time. We never applied log. It doesn't matter. You can stick with natural log. The answer will be the same, no matter what. You can apply natural log. I can apply common log. The answer will be the same. Because there is only one number that I raised 3 to get 2 raised to this.
Yeah.
So we can find 2 numbers. These are, both functions are 1 to 1. For a particular x, there is a particular y. For that x, there is one y. So So x minus 1 in parentheses log 3 equals negative x plus 4 in parentheses log 2. You understand that if we don't put parentheses around those powers and distribute log 3 and log 2 respectively, we are changing the problem. We'll never solve it correctly. So then I have x log 3 minus log 3 equals negative x log 2 plus 4 log 2. Right, I have to because it's linear. Although it looks so sophisticated and difficult, but it's linear. These are all simple numbers. So x, and I pull out x log 3 plus log 2 equals log 3 plus 4 log 2. You don't have to do 2 steps in one, especially on a test situation. I wouldn't do 2 steps in one. I will take my time, I will write it slowly, but obviously this was negative. So another thing that I think you learned, not to write minus minus and then perform the operations. Just take one term from one side, move it to the other, just change its sign.
Yeah.
That saves a lot of time and writing. So it was negative, I pulled it here, I took it to the other side, and since they have the same factor, common factor, I pulled it out. This was negative, I took it to the other side, it becomes positive. So then finally x is this ratio of this over this.
Yep.
So log 3 plus 4 log 2 over log 3 plus log 2. Now, throughout these 13 weeks, you learned a lot. Every now and then over the summer, if you're not taking Calc 1 over the summer, look through the material. Because when you come back in August, although now it's a breeze and you know it so well, you will say, what? Right?
Yes.
So please do that. Every now and then, just look at a few things and through your tiny notes, not necessarily solve problems. Okay, then I'll tell you a little story after part B. Log base 2 of x minus 5 minus log base 2 of x plus 3 equals 3. Where is my starting point? What type of equation is it? That's my first thought. What type? So I see log. Obviously, it's a log equation.
Mm-hmm.
I recommend, remember always that log is not a friendly function. By that, I know it's silly to say something like that, but what I'm trying to refresh your memory or just trigger your memory on is that log is a function with restrictions, like the square root and like the rational function, like tangent, like secant, like cosecant.
So x has to be
So from here, x has to be greater than 5, definitely, and from here, greater than negative 3.
right.
So when you overlap these two, what will be the common domain now? Because at this point, you may not need to graph it, but I'm not saying don't graph it. I'm just saying if you think that this is okay, not to graph it. So I have negative 3 to infinity, and then I have 5 to infinity.
So x is greater than 5.
5 to infinity. Which means if the equation does not have a solution that is strictly greater than 5, not 5, anything greater than 5, then I will say it has no solutions. And I'm done. Okay. So now I have to condense the left-hand side into log base 2 of
X minus 5.
awesome. And then I have to change it into an exponential. I shouldn't say I have to. There are other methods as well. But I think that this is straightforward.
Uh, 2 to the third is equal to x minus 5 over x plus 3.
And I know that 2 to the third is 8. And I will put 8 over 1 to remind myself that this is now, it started initially as a log equation, but now it's what type of equation?
Proportion.
Yes. Or rational equation of the type of proportion. Yes. And what can we do in a proportion?
Cross multiply.
Cross multiply. So then I have 8x plus 24 equals x minus 5. Now, see how many different things we test with one particular problem, like this one. Log, changing it into exponentials. It changes now into a rational, being able to solve a rational. And now it changes into a linear, being able to solve a linear. So I subtract x, so I have 7x, and then I subtract 24, and I have negative 20.
19. Oh, wait, 20, never mind.
Am I correct?
Yeah, minus 9.
So x equals negative 29 over 7, and I will put a big question mark there. Why? Is it in the domain? No.
No.
So what do I conclude about this equation?
No solution.
Very good. Good. Next question. What about 5? What about 8?
Maybe 5.
What about 7? Yes. Okay, so let's start with 5. So x plus 3 over x minus 2 greater than or equal to 2.
X cannot be equal to 2.
Careful. We will take care of that in a different way.
Okay.
But you're right. I completely agree. I cannot disagree with what you said. It's just that the method will take care of that. Just remember that I didn't turn off my phone. Sorry about that. Yes. First step. First step is I have to ask myself, what is it? And the answer is, it's a rational inequality. Then immediately a light comes on and says, I cannot get rid of the denominator.
Right.
There is no way I can get rid of the denominator. I'm not allowed to multiply both sides of an inequality by any quantity that has x in it. So then what are the options? What can I do?
You set to 0?
I have to have 0 on one side. I completely agree with that.
I know you're gonna have the chart. Also.
Exactly, but not yet. Not yet. Very good. Okay, what now? Remember, the chart requires two things. 0 on one side and a ratio, just one ratio, not a sum or a difference of ratios or fractions. A ratio here or a product. One. I can
Find the
have,
lowest common denominator.
exactly, exactly. Yes, have to find the least common denominator, and then now the numerator will become,
2x minus 4.
so I have an x plus 3 minus 2x plus 4. Are we in agreement with this so far?
Mhm.
Okay, so then the top is negative x plus 7 over x minus 2 greater than or equal to 0. Now this is chart ready. Remember, the chart cannot compare a quantity to another quantity. Can only compare a product to 0 or a ratio to 0.
Yeah.
So x is the variable in the problem. The top is negative x plus 7. The bottom is x minus 2. And then the ratio, negative x plus 7 over x minus 2. So at the top, I only need two numbers. And I have to be very careful and make sure that they are in ascending order, presented in ascending order. Because
Negative
otherwise, I
7
mess
and
up the whole thing. Say it again?
Negative 7. Or sorry, 2. No, that's 7.
2 and 7.
Yeah, 2 and 7.
So there is a 0 here, and there is a 0 here. Well, what happens to the ratio?
It's undefined.
Where?
2.
Very good. Undefined at 2, but 0 under 7 because the numerator is 0. Awesome. Very good. Well done. Now the sign. Well, I know how to start the sign of an expression. This is a polynomial expression, linear.
Yeah.
So what is the end behavior for this?
Positive and negative.
That's it. That's all I care about. Or you can plug in a number, but I think it's longer if you plug in a number or just look at it. Now, what is the end behavior for this?
Negative.
Right. So now the ratio of a positive and a negative is negative. The ratio of two positives is positive, and here is negative. Only now I look at this and ask myself, what do I look for? What do I pick? Which sign do I want that expression to have? And the answer is, I wanted it to be positive because it's greater than or equal to 0. Only positive are greater than or equal to 0. I look, I see positive, I choose.
Mhm.
So then x is in the interval. I cannot close at 2. Has to be open. But I have to close at 7 because of the equal symbol, and that's a bracket. Close or bracket, same concept. Very important